In this video, we're going to consider the gradient graph of cosine functions. So if we start off with f of x equals cos x, and we'll just look at the gradient function between 0 and 2 pi here. Alright, so if we start off at the start here, you see the gradient is 0. Now in this section here, you'll see that the gradient is a negative gradient, therefore we're going to expect the gradient function to be below the axis. So we have a turning point at 0 and a turning point at pi, so therefore the biggest rate of change, the largest rate of change is going to be halfway between, in this case at pi on 2. Okay, then what we're going to have between these two turning points is going to be a positive gradient. Again, the highest rate of change is going to be halfway between the two turning points. So if we just run the animation here, and we'll plot the gradient. So the gradient is a negative value. So the greatest rate of change is going to be halfway, you see, so that's why at pi on 2 we've got a turning point here. And the gradient is going to come up until it gets to 0. And it's going to be a positive gradient. And again, we got between two turning points. So the highest rate of change again will be halfway between, which at this point is 3 pi on 2. The gradient then will decrease as it gets towards the vertex here at 0, which it will pass through. So if we look at the gradient of cos x, this function, the red function that we've got here, is actually negative sine x. Looking at another cosine function, if we make the function y equals cos 2x. Alright, so what's happened again is you've had a dilation from the y-axis, a factor of half, which is squashed the graph up, you see. So we've actually got two periods within 0 to 2 pi, okay, 2 cycles rather. Okay, so what's happened here is you see the gradient, because you've squashed this graph, the gradient therefore is going to become steeper. Right, now at this starting point here, the gradient's still going to be 0, but if we run the animation, you'll see what effect that's going to have on the values for the gradient. So you see, because of this dilation, the gradients actually became a lot steeper. Because you're squashing that graph from the y-axis, you see the gradient then becomes steeper at all of these points. So therefore, when we're looking at this, it's still going to be a negative sine function. But because of this dilation, you're going to have the negative sine function. So this graph, y equals cos 2x, is actually going to derive to negative 2 sine 2x. The rule for the derivative of cosine functions would then take the form, if we said y equals cos f of x, the derivative dy by dx would equal negative f dash x sine f of x.